Good morning, colleagues. Today we are going to solve exercise 320 from the book Fundamentals of Electric Circuit of Sadiku. Good. This exercise asks us to determine the tension B1, B2 and B3, but applying new analysis. If we look, we see that this dependent voltage source is between B1 and B2, indicating it as a supernova. But this 12-volt source is also connected to point V1 and point V3, indicating that it is also a supernova. This is what tells me that from here, passing through here, passing through here, all this is a common point. Remember that when we make nodes, we assume that here it is as if there is a short circuit. This is all a single point. Okay, so, all of this that I've already finished marking as a supernova, so I'm going to mark the currents by the directions it's supposed to go. The first thing I'm going to do, which is easier for me, is to indicate a current that comes from here, from this point to ground. The other one, which is the current I, which is marked here, is the other direction of the current, and this current I is what will determine how much voltage there is in this dependent source. And the other one I'm going to mark as this way. That would be another. Now, I'm going to give them a name. I'm going to call them I1, I2, well, I'm going to leave this one as a bit. You will say, why didn't I mark a current here, either in this direction? Which direction? Well, it is assumed that if all this is a supernode, that is, from here to here all that is a supernode, a point in common, and the point of tension and tension at this point is the same, therefore there is no current flow through that resistance, right? It is as if you connected a resistor to the positive socket and reconnected the other end to the same positive socket. As they are the same voltages, there is no current circulation. That's why I didn't mark a current along that path. This is due to the analysis of supermodes that we are doing. Let's remember that like this source of tension, same source of tension is between B1 and B3, but at the same time here there is a source of tension between B1 and B2. In other words, this point in common is being shared between all that is noted here. All of this is a node. So, the node is this node. Well, it is the same node this, when we are doing supernode analysis. Well, that's why I only left it weighing 3 streams. So, if I apply the node analysis, I obtain that of all that supernova that I marked, I say, of all that supernova that I marked, I say that the currents that enter are going to be equal to those that leave, but I think that I only marked currents that they come out. So, it's going to be the current I1 plus the current I2 plus a current called I, which is this, so it's going to be equal to 0. Now, here the I1, because it is the attention B1, I am at that point B1 out of 4. Plus the I2, which is going to be the voltage B2 over 1 plus the current that you see here, which would be the voltage B3 over 4/9. Yes? All of this is going to be equal to 0. Now, if I multiply by 4, I'm going to get B1 plus 4B2 plus B3 equals 0. This is going to be my first equation, an equation with 3 unknowns. It means that I need to get 2 more equations to equal the equation. Well, then I'm going to get the second equation by doing a loop analysis on this loop. How am I going to do it? I'm going to replace. Let's observe that the voltage B1, this voltage is from this point to ground. Well, what I do is, I'm going to leave it here so that it looks good. I'm going to replace this resistor with a plus-minus voltage source. True? It's going to be P 1. Why more or less? Because the way comes downwards. Well, the tension is positive here and negative below. From here to this point I'm going to set the font slope. The slope source is 2 or the current. The size is equal to that current. And the other is this resistance that will be the voltage B2. I'm going to put it here. B2. So, if I do the LBK, I'm going to get minus B1 plus 2I plus B2 equals 0, minus B1 plus 2 times the I, but the I that comes here would be B3 over 4. P3 over 4 plus B2 equals 0. Good. So operating would be minus B1 plus this 2,004,500 B3 half. And plus B2 equals 0. Okay, so that's our second equation. I'm going to organize it here. Minus P1 plus P2 plus P3 minus. That's going to be equal to 0. I'm missing an equation. The following equation. Let's remember that the law of will that cast, that the voltages in a loop that they are going to make me, I'm also going to take now in this way. That is, no matter how I take the loop, the sum of the functions will always be equal to 0. I did this first, okay? Now I'm going to do a jump from here to here, a jump from here to here and a jump from here to here. The first thing that added was this, a loop from here to here, a loop from here to here, and a loop to here. This bow in red is the first one we made. Now I am going to make another bow that takes up the supernote that we are missing. I'm going to make a movement from here to here, then a movement from here to here, then a movement from here to here. That would be the other loop that I'm going to make. So, the same thing, from this point, this jump that is here, this node is still worth B1. It is not that it is worth B1, but that the source B1 is connected there, because at this point the 12-volt source is connected. Well, the other source of tension that I'm going to put, from here to here we already made the first jump, which would be V1. The other connection is between V1 and 12 volts, which would be, more or less 12 volts. And I'm going to finish here this node that is here I'm going to connect it with the node of V3 as if I were connecting a source here of V3. Which would be B3 up to here. Well, there what I did was the connection between, I'm going to mark it again. Between this would be V1, versus 1 is connected to the 12 volts and the 12 volts is connected to V3, in order to get the other equation. So, if I do the LVK here, I'm going to get negative B1 plus 12 plus B3 equals 0. So if I organize, I'm going to have here B1 plus 0 in the position of B2. B3 equals negative 12. From that I have the three equations with three unknowns. I'm going to Malta to resolve this. Well, here I have that the first equation was 1, space 4, space 1.com. Yes, 1, space 4, space 1, minus 1, 1.5. And the other would be minus 101. 1, 1, 0, for the side of B I have 0, 0, and negative 12. Zero, 5.0, 5.-2. And the solution is to control the times. So, here are the voltages 3, 4, 5 and -6. Well, then I'm going to put the result that you gave me here, -3, 4, 5 and -15. B 1 is equal volts. B 2 is equal to 4.5, and B3, at least 15. Ready? So, we check what the exercise asks of us, B1, B2, B3, and we find it. Well, see you in the next video.